Welcome to Dr. BT's Chemistry Essentials, A-Level Chemistry made easy. This is the third video looking at the quantification of solutions, and in this video we're going to focus in on dilution. So what happens if we take a solution and dilute it? How can we quantify that easily? As previously stated, in a solution we have two parts, the solute and the solvent. When we're quantifying a solution, we are looking at the amount or number of moles of the solute. Referring to N, number of moles, we're talking about the solute and not the number of moles of the solvent. Now, the number of moles of the solute is dependent on the volume of the solution. That is given in decimeters cubed, and also the concentration of the solute with respect to the solvent. You can see here that this concentration is just NVC rearranged, where it's the amount of solute divided by the volume of the solution. On dilution, what happens is we add more solvent to our solution. And what's really important to start to think about what's happened to the terms N, V and C when this happens. It's evident that if we've added more solvent, the volume of the whole solution has increased. What is important to note is that the moles of the solute that was once in the original solution, the old solution, is exactly the same as the number of moles in the new solution. You haven't changed the amount of solute at all, you've only changed the solvent. So N has stayed the same. Now if volume has increased and N has stayed the same, then as you can see from this equation, concentration must decrease. Intuitive, because we know that obviously even with something like a dye or squash like a Ribena, as you add more volume, i.e. water to it, then the concentration or the depth of colour in that particular drink is less. But the amount of squash, the moles of that solute, has stayed exactly the same. In order to quantify this idea, we just need to differentiate our MVC on this side to our MVC on this side. So we're going to call the old solution prior to dilution M1, V1 and C1. And our new solution on dilution is going to be N2, V2, C2. So as to our discussions earlier, N1 and N2 must equal exactly the same as the solute moles has not changed. As N1 is equivalent to V1 times C1, hence N2 is equivalent to V2 times C2, a really useful expression in order to work out the new concentration post-dilution. Rearranged C2, the new concentration, is volume of the initial times the concentration of the initial divided by volume of the new. And this is a really useful relationship for working out new concentrations if you have a solution and then you dilute it or you mix it with other chemicals. And this is going to be really key for any lab work that you do or any of the pH type calculations that you'll meet in year 13. So we're going to apply this idea to some questions. So here we have a typical dilution calculation. Pause the video here and see if you can have a go at working out the correct new concentration. So if when you calculated you got the answer of 0.10 moles per decimeter cubed as the concentration, then well done. Now the way in which we go about that is, again with all calculations, let's follow our 6-step approach. So firstly we're going to box the actual thing that we're trying to work out, and that is what the B of bug stands for, and then UG means to underline any given values. Worth noting here that diluted to means taking that 100 centimeter cubed, which is the initial volume, and making it up to 150 centimeter cubed. So we've added 50 centimeter cubed to the original volume. And wording is really important with these types of questions, and also the types of questions you get with these in year 13. Then we look at the equation that we need. Knowing it's a dilution question, we should be selecting this equation. Then we're going to check the units of any values given. Here obviously we've got concentration moles per decimeter cubed. Now when dealing with volume and looking at ratios, which is basically what this equation does, it doesn't matter what the units of the volume is, as long as both V1 and V2 match. So whilst these are both in centimeters cubed and the concentration in decimeters cubed, it doesn't matter because we're just seeing how many times V1 and V2 are related to each other. So as long as the units match, all's good here. So having said that, if you're a bit unconfident, then you can always convert volume into decimeters cubed. It will give you the same answer in this case. We then rearrange the equation that we've memorized. Do that with reference to the boxed value that we're trying to obtain, which is C2. So we're going to make C2 the term of our equation. So it's C1 times V1, and then we're just going to take the V2 over the equal sign. So whilst it's multiply here, it's going to become divide. And our next step is then to substitute in the values. C1, as you can see in the question, is 0.15. V1 is 100 centimeters cubed, and V2 is 150 centimeters cubed. All that remains is then to plug that into a calculator and get the answer. And the answer is 0.10 moles per decimeter cubed. What I'd like you to do now is pause the video and have a go at this question. Just be careful of the wording in the question. Okay, so if your answer was 0.085 moles per decimeter cubed, then well done. Now it's quite intuitive to some of you. You might not have had to use the equation in this case because we've got nice easy numbers. We're basically diluting a solution by half. However, we're going to quickly just walk through this. Okay, first of all, the boxed thing that we're trying to work out, the underlying given values. Now, one thing to be aware of is V2 is not 50 centimeters cubed. It says here when a student adds 50 centimeter cubed to 50 centimeter cubed of solution. So V2 is 50 plus 50. So sometimes you might have to be really careful with the wording and then manipulate the data that you've been given. Then we've got the equation. Units are absolutely fine because they're in centimeters cubed. They're matched in terms of both volumes. Then we need to rearrange. We substitute in our values. And then we just put that into a calculator and get the answer of 0.085. Again, whilst these values were nice numbers, this particular equation and its rearranged form is going to be able to help you work out any new concentration on a dilution problem. So that concludes this video looking at dilution problems with solutions. If you've found the video useful, ensure that you like it and then ensure that you subscribe to the YouTube channel for new videos as and when they're uploaded. The next video in this series is going to be looking at titration questions. All these videos looking at quantifying solutions are going to form the foundations for your ability to tackle year 2 type problems like redox titrations, percentage purity, and pH calculations.